Welcome to week six of AI for the for week six of AI Saturday Course Community Session ML Flip Course. So today marks the
Yes,
official. All right, thank you. Today marks like the end of week six. So I want to appreciate everyone. Thanks for sticking so far. Though I know it's been challenging coming from nothing to this particular stage. I appreciate everybody for for sticking with us and sticking through the course. Thank you and thank you again. So yeah, so what was okay? I would like to ask again, what was your highlight of the material that was released this week? Does anybody care to share? What was your highlights? There's no wrong answer. What stood out for you?
okay.
What made you feel odd? Proceed. I thought someone was talking just now. Ah, okay. If does anybody else want to talk about what stood out for them in the material this week? What is there any aspect they feel like was a bit challenging to them?
Yeah, so the like I said I watched the videos from this week, the three of them. So it was just the what do you call it, the in-depthness, like the part of um validation training. That part is a bit like I won't say complex, but you need a lot of mental energy to actually grab all of that. So yeah, that part, like the parts where there were equations and all of that, that was like it was quite new to me. So yeah, that part.
Okay, no problem. I think is the equations are very necessary because all everything we do in machine learning, everything is like they are mathematical, they are statistical. So it is not just like math. So there's a reason why we are getting what we are getting. So that is actually what we are. That's what the instructors were trying to ensure that they pass across. So even though in this in while writing your code in your day to day, you won't necessarily be you won't necessarily be writing those algorithm. You won't be necessarily writing the all those mathematical equations, but you need to understand what or whatever function you are calling, whatever stuff you are calling. You need to understand what exactly is going on and how it is doing what it is doing, so that you know if anything goes wrong, you know exactly where to debug. You know how to debug. You know when to debug, and you are able to understand the results you are getting. Are able to like understand it and also like say that okay, this is exactly what the algorithm is getting, and this is why it is getting it. So so even while you are putting it, there's also you also after interacting with your data, there's also a sense of something that you are expecting to get from your data. So if your model is not giving you what you expect, so then you will go in and debug what is wrong. So your understanding of what exactly is wrong, of how the model works on the ground, will then like will then will guide you on where to like debug, because it's a whole lot of process and you can't just like start doing it without a sense of direction. So today I will try as much as possible to not like engage the equations. I will try as much as possible to stick with the theory. Even though the equations are very, very important, but I will like make it more practical and make it more more theoretical and more code based. Exactly. Anybody else has anything to say before we proceed? Well, while we are while we are doing that, let me let me launch this poll. So I launched a poll. Please let us fill the poll. That's so that we can know. These are, did you watch this week's videos? So did you watch it all? Did you missed? Did you miss anyone? Did you? So what exactly is the? So, so the people that said have not started, is there a particular reason why you haven't started? Is it something from our side? Is it something you want to share with us? Is it something we can work on? The people that said two left, one left, is there an issue? Was the material like too difficult? What is the issue? Do you care to share with us? Or we should? Do you want to share with us? Nobody wants to share. Okay. All right. Mm, okay. 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 Um, the assessment. Okay. The material. Those of us that watched it. Those of us that haven't watched it. I want to know like how many of us like understood the concepts discussed. Was it challenging? Was it hard? Do you understood it? What? What? Do you understood it? Kind of. So kind of that's like 50-50, right? It's not like you understood it and you are not sure if you do understood, right? Okay. Elijah, do you want to unmute yourself and talk to something?
All right, Yamisha, can you hear me?
Yeah, I can hear you.
Okay. I was trying to find a quiet place. So, for me, I could not get to week six at all because after the Saturday session that we had, the extra, all right. So I
Mm-hmm.
really saw the need for me to go back to dive into all those techniques, the one odds, the label, and all of that, the back of words. So I needed to take a pen and and paper to write things out so that I can really process all those information. So for me, I could not get to week six at all because of some other things and works as well. So that's why I am out of that pool. But not to worry, I'll get to it this weekend. How to catch up.
Okay, okay, I mentioned this last week if you were paying attention, and for those that are in the same shoe, um, the material last week was much more in depth for this level. Mm. The thing is, it is much more in depth, and most of these things you can pick there. You can even like go in depth as we proceed. When we eventually, I think we'll still have a deep learning course later. So when we have that deep learning course, even and when we have a deep learning course, and we also have like an NLP NLP session. So with that will dive deep into this. This is what we thought is very, very surface level. It is still much that was what we thought that last week was very surface level. It was just to introduce you guys to the concept of NLP. I know a lot of people people want to work on NLP projects, but the NLP project you can work on right now is a bit like limited. So if you really want to go into NLP and if you really want to understand this, y- your knowledge of machine learning together will help you. So take it. I think you should. I will personally advise that you should take a break from that one for now because it is still like
No,
it is a whole
I'm
whole
done.
session on its own. Mhm.
Yeah, I'm done. Yeah, I'm
It,
done.
because
So
it
I
is a
just could not
what
catch
you
up
are
with
what
week
you are,
six.
is a whole field on its own. What you thought within a week is like people's like that's people's career. Do you get? So it is much more in depth than that. So just like it was just an introduction to a very very basic introduction. So please don't dwell too much on it. There's still you can still come back to it. You can pick it up as when you need it and as you need it. And if you want to do a project on something similar to it is not bad. But you like taking your time on it like that much right now. I'm talking about right now. It is you can still delve into it. What I'm just saying that it might be a bit challenging for you at this juncture. So please don't let it be the reason, don't let it weigh you down. Don't let it be the reason you won't be frequent in the so is that fair enough? Anybody else has anything to before we move on?
Hello?
Yeah, hello.
Yeah, good morning, everybody. So,
Mm,
concerning this past week's what will I say? Week nine
material.
schedule, yeah,
Week five.
material. Um,
Mm,
so I watched the first and the second lecture video, but I'm still like halfway in the lab slide because I'm trying to also do what he was trying to do side by side. But
okay.
I think I got to a part where I was trying to understand something he was explaining. I don't know. Maybe like during the course
Okay.
of when you're trying to delve into the lab into like in more details or something, maybe you get there and you can also help me.
Mhm.
Thank you.
Okay. You can talk about you can just what exactly is it?
So he was yeah, he's under the gradient descent part. Um
Mm-hmm.
and I think he was trying to a particular cell where he was using the learning rates, trying to because he was trying to say that yes, you can't just go from 0 to 1 because um like making that kind of differential is like it's too let's say heavy or something. So you have to take it like step by step, like step size, that kind of thing. So
Mm-hmm. Mm-hmm.
I think there was a part where he was trying to, I think he did, was it a for loop or something, that he was trying
Mm-hmm.
to iterate over, like using a point, like where he had A and
Okay.
B, that kind of thing. So
Mm-hmm.
there was
Mm-hmm.
a part where the formula part, like where he did -2 or something, I actually did not like understand like that particular
Okay.
line of code here. So when he
Okay.
generated his new A, so
Okay, no problem. When we get there, please call when we get to the notes because so you can call my attention to it. So
okay.
we'll just all right. So okay. So I also really cool. So I want to know how many of us like interacted with the lab notebook. The point that had challenges with run while running the notebook. Do you want to what challenge did you face? What challenge did you face? Do you want to talk about it? Okay. Um, okay. So, so how many of us have, I want to know how many of us have like started the assessment for the week. Okay. Okay. I think I saw Precious message that the date for submission of the assessment. The deadline for the submission is tomorrow night. Tomorrow EOD. Sunday EOD. So end of day tomorrow. So please submit your assessments before
So
then.
Sorry, please, where can I access the assessment? Sorry.
Oh, okay. Have you been receiving our emails?
No, I haven't. Sorry.
Oh wow. Okay. I'll post the link on the Discord channel. Okay. You can join our Google groups. Okay. Can anyone help me with that? Go to the GitHub channel of the course and okay. Okay. So I'll just paste the link to the Google groups. So join the Google groups and you'll be able to receive our updates and the emails. Okay.
Hello?
All right. So hello.
Yeah,
Okay.
sorry, I just wanted to ask a question. Um,
Mm-hmm.
I saw someone talking about concerning the capstone project. So, I don't know
Mm-hmm.
if is a good time to ask this question because somebody talked about ask a question on whether to work on an exciting NLP project. I just wanted to know whether because I was thinking the aim of the capstone project is encompass the whole scope, like to cover up the whole scope of what we've done or what we are going to do throughout the course of this AI Saturdays. But someone was talking about working on just like NLP projects, which is like solely focused on a topic. I don't know if you get my what I'm trying to ask.
Mm-hmm. Mm-hmm. Yeah, the thing
Like I
is,
just
it
want to
depends on. Mhm.
okay.
Yeah, the thing is, it depends on the scope of the NLP. It depends on the scope of the NLP topics. If it is something similar to it's probably web scraping. I just want to analyze data and probably do some, text processing or whatever it is. So we will accept it. But it depends on the project itself. Once the person, but the thing is, it should be within the scope of the project. But we did a brief introduction to NLP last week. So if the project that the person is submitting it still falls within the what's it called? If it falls within the scope of the project, then if it's called sorry, if it falls within the scope of the course, then sure, why not? So that's basically it. So, but I guess that's the thing. Ensure it falls within the scope of the project and it's not so. But then let us see the proposal first. When we see the proposal, then we'll talk more about it. Is that fair enough? So and I hope everybody's already in a group already. Are we all in a group yet?
Sorry, I'm not. I'm so sorry, but I'm not. Please.
Okay. Okay, I want to know how many of us have group members and how many of us don't have group members. I want to know. Okay, so for those that don't have group members, kindly I would say that just let us know on the Discord channel. Tell people that okay, you need a team and then team up with people. We won't be teaming you. We want you to work together with people and see how exciting it can be. So that's the reason why we decided not to group people. So you come up with your team and let's see what you come up together, come up with about the exciting project. So, okay, let me proceed. Please proceed.
Good morning. Good morning,
Good morning.
everyone.
Good
Let me
morning.
say thank you for all the good job you have been doing for us. I really appreciate. Though I'm having challenges, but that should be a personal something. I didn't want to use it to disturb the group. But
Mm.
concerning the capstone project, I'm yet to get a group member. So I don't know any of our member that I have not gotten. So please, I need to join with some team so that we can start coming up with something. So I've not gotten group yet. So let me let you know, sir.
Okay, please, everybody that hasn't gotten a group yet, please, it is very important you have a group member. You have a team member, a minimum of two and a maximum of five, like in a group. So please introduce yourself on the channel. Link up with people that also need a group, and let's see what you guys want to build. What you guys want to build, and yeah. So we are looking forward to it, and yeah. So this okay, but before I proceed, so I will know before I proceed, so I will know how what to dwell on. Do we understand the concept of the material? I want to know where we are having challenges, so that I will know if I should where to like fast track. I see Precious is telling that we should move to the lab. Is everybody on the same page about that?
Yeah, yes, yes.
Do we understand the theoretical aspect?
Yeah, well, personally, I do. Personally, I do. Yeah.
What are others saying, please?
Yeah, I feel we should like you do the lab because it will actually save time, and like while doing the lab you can like also try to explain like those terms like that in the lecture slides also.
Okay, so I guess I'll be shuffling between the two then. Okay. Okay. Let's see. Okay, but um I guess we are not so new to the concept of machine learning. If we all went through the material for the week, especially the first lecture which introduced machine learning was like very very it was simple. I would say it was easy to follow through, and it involved a lot of explanation. So okay, machine learning, as we all know, is okay. So let's say as well. Okay, can anybody just define machine learning in their own terms? Sorry, I've already. What do you understand by machine learning? What do you
Uh,
understand by the concept of machine learning?
yeah, let me just a very like crude, like should I say definition explanation. It's just like using statistical techniques to like establish or discover like a pattern in your data, something like that.
Mm-hmm. Okay. Okay. Does anybody want to give it a shot? Anybody else? Okay. Okay. Our instructor really like said it all. He said machine learning allows computers to acquire knowledge from data without the need for explicit programming. So as we have seen in our material and in the lab, we said that the process of machine if you are using machine learning, you don't ex- we give it data, and then we expect it to learn like the different processes, the different complex interrelationships within our data that eventually makes our output, so that when we are testing it on external data sets it hasn't seen before, it will be able to like work properly, that so that it can generalize and work, and it can work on unseen data. So that's what machine learning basically is all about. So these are different applications of machine learning, self-driving cars, fraud detection, spam filtering. I'll just do a brief run through of these slides since we want so that we can go to the lab. So okay, a label and a feature, a model, trading, and inference. Okay, before we move, does anybody know why do we split our data sets? Why do we split our data sets?
Uh, like the purpose, like on the screen, right? You can see inferencing. The purpose of machine learning basically is like for inferencing. So how do we know that the our inference is like the model works well? There's no way to check that the model works well. So the only way is to split it, like have a separate part of your data sets that you use to measure how well the data set, then the model is, performing. And then if you feel like it's not performing well, you can go back again, reiterate, and all of that till you reach an acceptable, performance. Then you can now go ahead and start like the inference part. Yeah.
Okay. So okay, thank you. So thank you. The main reason why we split, thank you so much. The main reason why we split our data sets, we normally in real life we split our data sets into three. So we do training, evaluation, and even test sets. So while training our model, our the while training our model, it is only exposed to the training data set. So after a while, then we introduce our evaluation data set. So which helps us each helps us measure how good how to measure how it helps us to measure the model performance. So then we'll know, okay, is our model like working well, or is it not working well? So it's a very, very important method. So we check our model performance, so we know, okay, is this working well? Whatever I am doing, is it right? Is it correct? Is it making my model move in the right direction, or it is like doing what it's not supposed to do? So that's majorly what the evaluation data set does. They also have a test set, which after the different iteration, after different correction, so you now test it after building the model. And now after getting the model, now test it on another set of data that it hasn't seen before, which is now the final test set. But regardless, for this course, we'll just take with train dataset and test dataset. So we are training our model on the train dataset, and we'll evaluate it on the test dataset. So the reason why, and there's a reason why we split the dataset before. We need our model to be the reason why we are doing machine learning is so that when our model sees something that it hasn't seen before, it's able to like use the knowledge of what it has learned in the past to to work on this current challenge. So if we don't just want it to say that, okay, I have seen this before, this is it. No, that is then if that is how our model is working, then it's machine. So us incorporating machine learning is a total waste of time, waste of resources, waste of whatever we have invested in it. So we want our models to be able to like generalize on unseen data. So that is why. So we split our data sets so that what it has seen in the training data set is not present. The data in the training data set is not present in the test data set. Okay, and I guess this you can see features, model, training, inference. So these features are the what are model these are They are the input variable that our model uses to learn, to predict the output. So that's basically, so the features are the yeah, that our model like learns and absorb in order to learn, in order to match the specified output. Okay, so then let me say, okay, this house predict what kind of task can we call this house price prediction?
Supervised regression learning. Supervised learning regression tasks.
What about spam?
Classification, supervised classification.
All right. Does anybody has a different view of that about that? Does anybody has a different view? Okay, so I guess that's so. And okay, why is this? Why do we call this regression? Why do we call this supervised learning? Why is it regression? And why is it supervised?
It's supervised because there is features and label. I mean, it's we know where we want to get to. Like there's sample of where we want to get to. That's why it's supervised, and it should have been, if it could have been unsupervised if we don't have the label we want to actually get to, and we just want to like kind of categorize them in terms of cluster them. So, and it's regression because it's continuous. Like it's not like discrete. That's for the price. It's regression because it's more like a price of something like numerical, like it's continuous. Then it's class. That of clustering is classification because it's either
Sorry, you said
it's
clustering.
spam. Sorry, I said that of spam. Spamming, the classification of spamming. It's either it's a spam or it's not a spam. So it's more of like it's either this or that. So yeah, I think so. I think that's answered.
All right. So if you are if we want if we have a task that involves grade of people in a school, so um 70, let's say 70 and above A, 60 to maybe 60 to 69 B, so stuff like that. That kind of task, is it a regression or a classification task?
Sorry, I didn't get your question again.
If we are classifying if you are classifying the grade of students for a particular course, okay, 70 A, 60 to 69 B, and stuff like that. So what kind of task is it?
Yeah, it's classification. What is it called? Classification, because it's still of like of a similar bound. Either we fall in between A, B, C, D, and F. So it's still kind of, but it's not just binary classification. It's multi variate classification, something like that.
Multi-class. No problem.
Okay,
Okay,
multi-class.
if
Okay,
I
yeah.
if I do you want to talk about it? Okay, since
Hear
if
me?
I is not okay,
Can
I
you hear
can
me?
hear you. Yeah, I can hear
Okay,
you.
she said exactly it's like the class bound are fixed A to F. There's no 8.5 or 8.6. It does not go continuous. So it's already have the features of a classification.
Okay. All right. Thank you very much. So I hope that is very explain. That is that explains itself. If we are, but if we are not, what if we are not like predicting the grade? We are just predicting the score. What would that be? If you are not
Regression,
predicting grade,
regression.
exactly, exactly. So thank you very much, everybody, your for your so approaches to ML. We have supervised, unsupervised, semi-supervised, and reinforcement. Okay, anybody wants to tell us the difference between all of them?
Okay, let me just go. Let me go for it. So, thank you, Mr. So for
Mm-hmm.
supervised learning, so that's
Mm-hmm.
it entails, you training your model with a trainer. Trainer will be in this context will be a data that has been labeled, to give it to prepare.
Mm-hmm.
That you are training the model
Mm-hmm.
with, with the label, with the truths being known. So he learns those patterns, then he now generalizes for
Mm-hmm.
unseen one. So that was supervised.
Mm-hmm.
While for
Mm-hmm.
unsupervised model, so this time around, you just throw the model out there to just learn, those patterns. So without labels, without the true value, so he just learns patterns from the data. So this time around, it's not being supervised. Does not have a teacher or a trainer in this context. You just learn and infer patterns by itself
Mm-hmm.
without supervised, without being trained. Then the last one, the reinforcement learning. So this deals about having an agent that is able to carry out, agent to be a model in this context, that is able to carry out tasks by learning from its environment. And often it works by each time you make the correct guesses, it's being rewarded, and if it fails it's being penalized. So that way it learns and grows to perform a particular task. That's what I can say about those three things. Thank you.
What about semi-supervised?
Semi-supervised. Okay, semi-supervised would not be like, like a major, like having the best of both worlds. Having, for example, you have a model, one training model. So you are training the model with some set of data now. They are labeled. You know why? So that well, let me make it for myself. So you have particular problem you want to solve, largely supervised, largely unsupervised. So you now have the
Mm-hmm.
data. Some parts are
Mm-hmm.
some parts are labeled. They are labeled. While other parts are not what they are not labeled. Are you with me? I don't know if I'm
Mm-hmm.
making sense.
Yeah,
So
continue, proceed.
okay, so now the model will infer, from that set of, you know, label to now generalize into, to now guide it,
Mm-hmm.
in how to also, work with those unlabeled data. I guess so.
Okay. Yeah, yeah, yeah. I think that's fair enough. I think that's a fair shot at semi-supervised learning. So semi-supervised learning, you first like train your model on you first do supervised learning, then you do unsupervised learning. So you are not doing a total unsupervised learning. So it is major. So okay, let's say you want to do, let's say in stuff like data annotation. Let's say stuff like that. So let's say if you just say that, okay, I will label some few examples and then show it to the model. So now understand the features that made us choose this label for this particular feature. Then okay, based on that knowledge, do the same for the unseen data. So that's basically what semi-supervised learning is. Semi-supervised learning is. Yeah, I think that's nice. Let's move. So yes, okay. So semi-supervised learning is now divided into two. That's what we have, classification and regression. So that's basically, so I don't want to dwell too much on the. So as you can see, I said that semi-supervised falls between the supervised data and unsupervised data. The data set contains both labeled and unlabeled data points. So it uses its knowledge from the labeled dataset to generalize on the unlabeled dataset. So reinforcement learning, and one place where reinforcement learning shines, where you can really see it is okay, in training in training post training of large language models, there's reinforcement learning. But I think one thing that we can really understand is in all these self-driving cars. Let's say you put a self-driving car in a particular environment now. It doesn't, if what a human brain can process at a time, like at the spot, that okay, this road, if I pass this place it will be slow, this route if I take it it will be faster. I can process it. I can say that, okay, seeing the two routes, like I'm just talking about, or so okay, let's say two lanes. There are lanes now. Okay, this lane is faster, this lane is slower. I can process it in my brain, and I consider, okay, this is a let's say this lane is like going, this lane, the other lane is coming. I can process it just seeing it, but that is not the same for a machine learning model. So you have to find a way to make them understand and make them learn from the environment. So now, okay, one, so it makes you make them understand. Okay, this lane, oh, if you are on this lane, it will be slow. Then you penalize it. So and then if you move to this lane, it will be fast. If you move to this lane, it will be faster. Then you reward it. So the model, so your model now will now be what your model will now be doing is trying to optimize for the best reward. So let's say if you move to this extreme, it is you get to let's say you get 2 marks. If you move to the middle, you get 1 mark. If you move to this left, you get 0 mark, or you even be penalized, you get a negative. So it will say that, okay, which path do I take that will make me like have the best reward? So it will always optimize for that. So that's basically what reinforcement learning. That's basically what it does. So now to speed this up, this is where everything starts from. The machine learning. It starts from the linear regression, the classification, everything. It starts from y equals to mx plus, which is the equation of a straight line. Basically, and this instructor also did justice to that. He said he was telling us that basically what we do is about drawing line. Yeah, basically drawing line. And in our so, someone said it's not visible. So can you all see my screen? Is
Yes,
my
I
screen
can see your
visible?
screen. Yes, I can see your screen.
Okay. So
I think it could be his network. That's Israel's
sorry.
network.
Okay, usual, please check in. Okay, so as I was saying, we are basically drawing the line of best fit. So what can anyone just tell me if we did mathematics, in secondary school mathematics, do you understand what is called line of best fit? What do you understand by line of best fit?
So, like, the line of best fit is like a line that minimizes the loss. It minimizes the SSE, I think so. Like, I think it's standard square error, or it minimizes loss. Let me just put it that way. Is the line that yeah, I'm trying my best, but it's the line where when you place that line on the graph, it is the lowest possible distance between all the points, or all the data points, the lowest possible distance between all the major points. Yeah, so something like that minimizes loss.
I think what we wanted to say was mean squared error, but mean squared
Is it
error is
miss?
not the only.
Yeah, so I think can I chip in on line of best fit?
Yeah, sure.
So like in a more lay aspect, it's more of like the lines that actually the lines that actually capture most of like most of the points in the on a graph, something like that. So if there are numerous of points on a graph, the line that capture most of the points is line of best fit. Something.
Okay. 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 So it is so, and mind you, means okay. Back to Izundu. Sorry, Izundu. I don't know if I'm pronouncing that correctly. Pardon
It's,
me.
it's, it's
So
perfect, yeah. It's perfect. Yeah, perfect. Yeah.
okay. So and thanks so much, Abdul. Thanks so much, Elijah. Is the line that passes through all data points as best as possible. Um, it's a, it's a, the thing is, the line of best fit might not like it depends. It depends on your data points, what you are plotting. What you just need to know is that the line of best fit, the line is the one that the one that has when you draw that line, all the data points, like they are very much close to it, as they are the closest to it. It might take majority of them and it might not. But the thing is, it is as when that line is plotted, it has the that line minimizes the error. And what is the loss? There's a cost function. Okay, the cost function is okay. Let's say this is. Can you see my cursor? Can
Yeah,
you see my
yeah,
cursor?
yeah.
Okay, you know what? Let me move to the next. Let me move to the next slide. Okay, look at these three. Look at these four lines now. Look at these four lines. Which of these four lines is the line of best fit?
The orange one, the orange one, the one in the middle,
Hmm?
the orange one.
Okay. So okay, the thing is now, can we all count the number? Okay, the orange one. Can we all count the number of points, data point that passes through that the orange one that it ticks?
Like five or six, like five
Uh,
or
uh,
six of them.
and how
Do
many
we
data
count?
points do we have?
Yeah, like one, two, three, four, five,
It's
six,
eight,
seven,
it's
eight, nine,
seven,
10.
and the was able to touch five. Then one at different sides. So it's perfect.
But how many data points do we have in total? 1, 2, 3,
Like
4,
about
5, 6,
12
7, 8,
also,
9,
or
10,
13,
11, 12, 13, 14, 15, 16,
16,
17, 18.
18. Okay, 18.
18, and it's storage it's passed through 1, 2, 3. Let's say is 1, 2, 3, maybe 4, maybe 5, 6, 7, maybe 8. Out of 18, Abi, how many did we count it?
18. 18.
Exactly. So it's touched 8 out of 18, but we can assume it is our line of best fit. It is not passing through, mind, it is not passing through most of the data points. The only thing is that if we are to calculate the error, even though we are just saying it, we are just saying this offhand. We didn't check. We didn't know if we didn't check. We haven't checked, and we haven't like confirmed if that is true. But let's just assume that's our line of best fit. The reason why we are choosing it out of all of this now, we are choosing it as our line of best fit because if we are checking like the proximity to all the other data points, it's like it's able to balance well those that are to this side and those that are to this side. And look at this now. This um for this point, which is, let's say this is one. Let's assume this is 130, right? At 130, as the number of bedroom, one as 130 number of bedroom. Okay. The house price the house price is 30. Let's say probably 30 million naira. Let's assume this is in million naira now. It is telling us this is 30 million. It is telling us the data point is telling us this is 30 million naira. But our model is telling us that it is around maybe 26 million naira. So the difference between this data point and what our model is predicting is what of this
The
data, this
loss.
singular data
The
is the
loss.
loss. Yeah. So we can just call it's for a single one. I can call it the cost function, and then for everything we can say a loss function. So let's say the difference in is and this is the cost function. So that's just like the difference between our prediction and our true value. So what machine learning does is to try as much as possible to say that when we average the difference between this data point and our predicted data point, it is as minimal as possible, so that it isn't just like favoring some data points and tilting towards some, but it is not favoring some data points and then it is like no, feel it is performing woefully on another data point. If we should tilt this orange, if we should tilt it a bit now, we can say that's probably to okay. It's already working perfectly at this. It is already working code here. But if we tilt it so that it can pick this first three at the bottom here, it can be working. It will be over. It will, you can say it is overfitting at l- at at some level, at some values, and then at some point you see that it won't be working perfect, because if we tilt it, it will pick this point, and it won't be able to pick this point. It won't be also be able to like generalize well even at this medium point. So it's just about you get ensuring that all the data points like are catered to. That's basically what our line does. So it's the line of best fit, and that is what we'll get to gradient descent. So this okay, so this is what we are as we all know in the line in the equation of a line. I hope we're all familiar with the equation of a line. I hope so. If anyone is not familiar with this, you can just like let us know. But I will assume that we are all familiar with the equation of a line at this point. And since we have all watched watched the video, we would have familiarized ourselves with it. So this is our y. This is our prediction. This is what is this? What is this? What is this? M?
Like slope or grade, yeah, slope.
Are you sure?
Yeah, like
Yes, no,
if we're
it's the
using y
slope
equals the
of
slope.
gradients.
Yeah, or gradients.
Are you all sure? Then what is this? If this is slope, then what
Intercept,
is this?
intercept.
What is? Are you sure it's intercept? Which
That's the
intercept?
y-intercept. Y-intercept. See?
Okay, okay, good. So yeah, it is the slope. I was just when you were saying the slope of gradient. What is the difference between slope and gradient?
I think they're the same, like synonyms.
Are you sure?
Yes, boss.
Don't be confused, please. Don't be confused. So this is this M is the slope, and this C is the y-intercept. Emphasis on y-intercept. So when we are not we are not rewriting this into machine learning. This y is our prediction. This is what we want to predict. This is what we want to predict. This B is our call it bias, and this W we call it weight, and this X we call it this is feature. So does anybody understand what this weight, what exactly we mean by weight?
Okay, so let me just speak to weight. So now, well, I believe weight should be the level of importance that a given feature we have on that particular model. So it's how the model is able to maybe pay attention to or give a particular feature some level of importance. So the one that I believe the one that have the higher weight should have a better predictor importance to the model, I guess.
Okay. Yeah, thank you. So this thanks for that. So this the number of features you have will determine the number of which each feature will have which have its own corresponding importance, which is represented by the weight. This weight is telling you like, okay, how much how much attention is how much does this how much how important is it to our prediction. How so this is all this is computed by the model. We cannot compute it, but it is computed by the model itself. But you need to understand how what exactly is going on. So each feature, if you have 50, if you have, the number of features you have will determine will have a corresponding weight. So is that clear by everyone? I'm just like going through this. So training a linear regression model means learning good values for the weight from labeled examples. One thing I need you to know that the weight, they are not, there's a is a parameter. Hmm? Okay. Does anybody what's the difference between a parameter and an hyperparameter? Does anybody knows that?
So like the parameter, like you said, the model computes that for you. So hyper parameter, you have control over it, like learning rates and stuff like that. You have control
Mhm.
over it. Yeah.
Yeah, exactly. So hyperparameter. So I want us to understand this aspect before we move to we'll do the lab. So if we understand this aspect, then it won't be hard when we get to the lab. So weight is computed by the model itself, while I, I mean the parameters, which includes weight now and even the bias, is computed by the model itself. We do not have power over that. It is initialized randomly, and then the model now tries to um personalize it to your use case. Let me say it that way. It will like slim fit it, like, do you get? I'm trying to. It will just like it is. It is like you just have a material. You buy a material from the market, so you now give it to your tailor. Your tailor is your model, so it measures you, and then it gives you your tailor will now give you. Will now sew what fits you. You get, and it is for you. If another person's wear it might not be able to fit the person the way it fits you. So for your specific use case, now, your model will like it will initialize the weight randomly, and then through iterations, it will now like perfect it and say, okay, what works best for this specific use case. So the difference, and if it is not working how it's supposed to use, you can now change different hyperparameters. Like, okay, let us try this, let us try that. And before you even try that, try all these hyperparameters. You need to understand what exactly what exactly is your model, what exactly is wrong, and what exactly those hyperparameters, what exactly are they doing, so that you know what you are changing. So in supervised learning, a machine learning algorithm uses a model that minimizes the loss. And so loss is a penalty for a bad prediction. So it is a number indicating how bad the model prediction was on a single data point. If the model's prediction is perfect, the loss is zero. Otherwise, the loss is non-zero. Okay, so yeah, this is what we call a line of best fit. So you see, look at this part, look at this line of best fit now. Even though I'm not saying it is perfect, it might be improved on though. What I'm saying is that it's it is okay, it's only touching this data point directly. It's only touching this data point directly. It's not touching the other. I'm not saying this is the best. I'm not saying this is the best. This is the line of this is the best this model can do. This is not the best this model can do. But for this specific line of best fit, it is only sticking to a singular point. But it is ensuring that it is in relative position to others. Compare it to this. This is just like your model is this is telling you, if you are saying this kind of stuff is just telling you that your model is not learning anything. So whatever you are doing is probably wrong. There's a major thing wrong somewhere. So you need to like go back to the drawing board and rethink your approach. And probably there's a bug that you haven't caught. So you need to go back and say that there's something wrong. So that is what this is telling us. Then, is the regression model performing well? So, back to this is so it mean squared error. So the mean squared error is what is now what we use. So is cost function. So okay, the difference between the observation and the prediction. So it's whatever it subtracts the difference. It subtracts it observes the difference between your observation and your prediction. So let's say for this one now, this is the prediction. This is what your model says. So it will take this difference this is the prediction. This is what your model predicted. It will take this difference as well. And for each of the data points, it will take all of those difference and it will take all of those difference and then square it. It will take all of those difference, square it, and divide it by the sum. So you just have so it will average it averages it averages it averages it. That's basically what it does. So we also have you can use mean square error. There's mean absolute error. There's root mean square error. Root mean square error is just like whatever after getting this, you find the square root. So example of linear classifier. Okay. So let's come to this linear classification. So this you have a line now. You want to This is linear classification. Okay, don't let us before going to linear classification, let us go to the notebook a bit and see. Okay. Okay. Can you see my notebook?
Yeah, yeah.
Yes,
Okay.
yes.
Okay. So this is the notebook. So let me just run this. These are necessary libraries. That's so I don't if you've interacted with the notebook, this is just giving us a plus and then so look oh, it's already 11. Okay, I was trying to see how fast. Okay. Um given that we know that y equals to 2x, so what is y? What is y in this case? What will be our y here? Can we all see my screen? Okay, let me zoom in. Is my screen visible?
Okay, 20. 20.
Exactly. It is 20. So you can just say two, two, two star x. So for the value of y for x equals to 10. So what is x equals to 10? Because it should be 20. So y equals to 2x. So that's basically it. So I expect us to have done all these are very, very basic. What will be this one? What will be the value of y here? Looking at this table, what will be the value of y?
So like I don't get like what would be the value of y if like we don't have a value for x like or
Okay, what's the form? Okay,
Three
what is the
y is equals to
formula? What's the
3x.
okay the formula? Sorry,
No,
apologies. My
x.
question was no.
It was not clear.
yeah, because you can't find y if you don't know what a is.
Yeah,
That's
yeah.
why.
So I was just trying to infer from this relationship what. Okay,
3x.
are you sure? Are you sure?
Yeah.
Somebody
Yes,
can somebody else
I
check?
am.
Are you sure? Okay.
But
Okay.
Seems
This is 3. Okay. But I think this
it's
is
not
this
working
is
for
6
that
at
one.
6. Yeah, it's not working for this, but yeah. So y
Except
equals to
if
3x.
except if we
Exactly.
are going to check it in another way, but yeah, it's not working for that one. Why not
Okay. Now,
x squared plus
I think you
2?
have to
what about
manually
this?
calculate a yeah.
What is the relationship between x and y here? What is the relationship between y and x?
2x plus 2.
2x plus 2. Does anybody has a contradicting answer? Does anybody have a contradicting answer? Are we all agreeing? We are voting for Abdushakur. Abdushakur for president. Y equals
No,
to
no.
y equals to 2x. So why not? Why not? Please, oh. I want to I want to know a president by relation. This means I know the president. So 2x plus 2. Okay, let's just troubleshoot the Abishako hypothesis. So let's if for x equals to 1, for x equals to 1, that was 2 times 1 plus 2. That is 4. Okay, correct. 2 times 2 plus 2. That's equals to what? 6. That's tricky. 3 times 2. I mean, Abby, 3 times 2 plus 2. That's it. Well done, sir. So that is very, very nice. So, but one thing I just want to, so these two now, these two, in our equation, what's it called? In our equation of line, which is the equation of which is machine learning equation. What does these two? What does it stand for?
Bias.
These two anchor.
Which of the two? Sorry, I didn't get the two. There are two twos.
Okay. These two at the
Yes.
end.
Yeah, that's
The two
like
at the end.
bias or y intercept.
Are you sure?
Yes.
Very sure.
Yes.
What about these two?
Gradient or slope.
All right. That's great. Well done. So, you guys, who will come and take over? Somebody should come and explain this thing. Let me to come and sit down and learn from you guys. Okay, so this is okay, now let us plot it. Let us plot our line of best fit. You can see if we add we labeled this part, it's okay. This is 2. Yeah, we know this is 2. So this is line of best fit. I don't want to go through that much. Okay, this is our line of when we plot our line of best fit. 2x plot our line of best fit. This is what we get. Okay, that's for a different plot. This is for a different plot. So our what's it called? Our loss function. We calculate the difference between A and A and A. What will be the for this part? These ones now. What will be the cost for each of those data points? Each of these data points. What will be the cost function?
0. Like y, should I say y equals to 0? I mean 0,
The
basically.
cost function, yeah. The error is 0. Yeah, that's because it is actually passing through them, so there is no 0. So the error function for this particular for this particular um for this particular stuff, it will be was the sum of this error, this error, this error, and this error. So now, so far we are assuming that there is a linear relationship. We are assuming that there is a linear relationship between like our x and y axis. So for this we could be assuming that there is only x and y, or there's a linear relationship between the x and y axis. So okay, this is what I hope we all understood what the error function is. So do we understand this now? So we are considering not just a single data point, so we're considering all the data points, so which is what, and then we'll now divide it by the number of data points. So okay, let me move to, okay. Look at this sample too. Look at this example. This is what I was also trying to explain. This is the line of best fit. Hmm? But see, it is not picking any data point, but it is the line of best fit. Why? It balances like all the data points. So it is not, so we can say this point, this one now, it generalizes. So if you wanted to pick any of these data, it will not perform well. There will be, like, the loss function will be higher. At this point, we have the minimum um, loss function. I hope you understand why this is not like picking any of them. I hope there's no confusion so far.
No, it's fine. It's fine.
Mhm. We can see we have 5 data points above. We also have 5 data points below. It is balancing it, and so we can, and if we're able to like calculate the loss function, this will give us the minimum. Yeah. So now this is where this can now get a bit tricky. Remember, I said that the weight for each of our data points, I mean for each of our features, the weight for each of our features is like, it is initialized. We don't specify it. But it is initialized randomly. So like the model just like starts it randomly, and then so it now tries to like slim fit it to your size. I do even give a bit of room for, if you, even if you like, if you have a weight change, it will say that okay, this it will still like, it will still fit you. Don't worry, it's still your clothes. Like if you still have a slight weight change, not a massive weight change. So if your model, if it initializes it and then it starts from this point. Hmm? Okay, this A, now we can say that, okay, let's come to gradient descent. We want to let's go, just let me come to the gradient descent aspect. Where is the plot? Okay, let me use this plot. I thought there was another one. Okay, if your model initializes the weight, and when it initializes it, the weight is at this particular point. It will, okay. Before I proceed, does anybody care to like explain the concept of gradient descent using these plots? Does anybody want care to like explain the concept of gradient descent? There's no wrong
That's
answer.
like basically, yeah.
Okay, wait, before
Gradient,
you proceed, wait, first question. It's like only is on to Abdul Shakur that are in class today. I think Ifeanyi and Elijah, they are chipping in once in a while. What is wrong? What is the problem? Is it like, okay, before, is it like, I want to know, what is the issue? What's the challenge? Is it like we don't understand these concepts? I don't want to just like move on because only those few are participating in the class. Are we following? I want to hear from others.
I've been chipping into.
Oh, who is that?
I am
Oh,
following
Chito. Okay, okay,
actually.
okay, okay. Okay. Yeah, I know Elijah has been chipping in, but I'm just concerned about others. I can see we have Obama on the call. Wow. Sorry, I saw one person that is Obama. Marvelous Obama. Wow. Hi, Madam President, former first family of the US. Are you related to Obama by any way?
We are all
No,
here,
no.
sir.
Sorry?
We are all here, sir.
Okay. Okay. I want to like shoot my shot. I saw that Obama is on the course, so I don't know. I don't mind an appointment by the US government.
At least now you know your president now. At least now you know your president.
Like that. At least I'm one person away from Obama, and I can be two persons away from President Trump. Okay, but jokes apart, I want to know, like, are we following? Are the concepts to like are the concepts to uh are they too advanced, or should I take it down a notch? I just want to know, please.
Sir, to me,
Fine.
I will say you should take it down a little bit so that we will understand.
Okay. Who spoke just now?
It's Godwin.
Okay. Godwin. Okay. 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 So far, is there an aspect that is there an aspect specifically that you don't understand?
Okay, and anyway, besides, I'm just joining the class just now, so I was not around when they started from the beginning, so like it's something, though I have learned a little about it before, but it's something is still like new to me. That is why I'm like somehow confused.
Okay. Okay. So I guess Godwin, did you watch the week's material?
Yes, yes.
You watched the three videos.
No, it's just one I've done. I'm done with.
So like say this that's probably what caused the stuff, because the pace I am moving at is that I expect us to have gone through some stuff, and like I have a bit of knowledge, and then I'm just like coming to like build on
Okay,
that.
okay, sir.
So
Maybe
the
I'll
thing
go
is,
through it later, sir.
so please go through the material for the week later, and go through this recording again so that you understand. Well, this is also recording, so
Okay, sir.
this, and it will be on YouTube. We'll also share it with you guys. So we'll share it in the mail. We'll share it
Okay,
in the
sir.
mail after the call. So please go through everything, and then if you still now feel confused about any concept, please reach out on the Discord channel. I'll try as much as possible to answer everybody's question. But please,
Okay,
if I don't know what you don't understand, I cannot come and pick your brain to say that this is what you don't know. Is that clear?
okay, sir. Okay, sir.
Any other person before we move further? So are we contented with this pace, or I should slow down a bit? Ah,
Sir, I will say you should
wow.
just continue since we go
Yeah.
through the previous one. We
Ah,
should just continue with this pace, sir.
okay. Oh. But I don't like how we are not responding now. Do I have to throw dollar bills again? When dollar bill was raining, I knew how we were all interacting in this class.
The dollar is
Don't
very
worry.
important.
Yeah,
Please
we can try
motivate
that.
us.
Yes, sir. Yes, sir.
You
Yes,
don't know
sir.
when
Maybe
dollar
maybe
bill
if you
will
try
rain.
The
that,
dollar
it
is
will
a
happen.
motivator.
You don't know when the dollar bill will rain again. Don't worry. Okay, so okay. Does anybody
Maybe you can
before
you
does
can
it,
surprise us with your own dollar.
I laugh and dollar. Okay. Does anybody care to like explain the concept of gradient descent? How do you understand this? There's no right or wrong answer. Okay, no, there's a right answer though, but nobody's penalizing you for the wrong answer.
Okay, let me just try. Because you were already talking about the cost function. So um, the cost function, like the goal is our goal, like when building a model or something, is that we want the cost function to be minimized as much as possible. So like that's what
Mm-hmm.
gradient descent does. It's trying
Mm-hmm.
to get the lowest possible value of the cost function, something like that.
Mm-hmm.
Yeah.
Okay, thank you so much for that. Okay, let's just assume that this y-axis now, this is the cost function. This this is our what do I call it now? Okay, let's just say these are cost these are cost function. What can I call it? Forgotten. Okay, this is okay. We want to calculate our gradient descent. Hmm? So gradient descent. Okay, as I said earlier, our weights, they are initialized randomly. They are not like initialized, like our model just like starts there from a particular point and they fit there, as I said earlier. So if your model initializes it and it starts from somewhere here, you can see the cost function is and you calculated the cost function. Hmm? The cost function is somewhere here. You can see we have a very, very high cost function. So what the gradient descent does is that it helps us to move down, it helps us to move down this slope gradually till we get to this point where we have the least cost function. And how does it, that's basically what gradient descent is an algorithm, it's a very powerful algorithm that helps reduce it. So at this point, I can say that this is at this point when your model, when your cost function is at this point, like, okay, it is already at the least it can be. This is the best your model can be. So how does it do that? Okay, it's at this point now. Okay, let me come back to the slide. Let me show you the okay. Have we gone through the gradient descent formula? I don't think so. Okay. 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 Is that okay? Reduce. Okay. Let me come here briefly. Let me jump to this slide briefly. So reducing loss iteratively. So I like the way the instructor said reducing the loss iteratively. It is not a one-time process. I would say it is a continuous process. It's not just a one-time thing. You keep updating the weight. So let's look at this. So okay, we begin our training by starting with our initial guess for the weights and biases, and then iteratively adjust the numbers until we get weight and bias with the lowest loss. That that is very simple as it can be, right? So let's come here. Gradient descent. Gradient descent is an optimization algorithm used to minimize our loss function. The idea is to iteratively adjust the weight of our model in the opposite direction of our gradient. But one thing I just want everybody to know that in your while building your model, you won't be manually calculating your gradient descent. The all these libraries that we are doing, and it will be calculating it automatically. You won't be writing a function, you'll be writing code to calculate gradient descent. But you need to understand what exactly is going on to know what to improve on. Okay, so let me just explain this. Okay, let's say when our weight was initialized, right? This this is our weight. The correct when as immediate as the instance when our model was initialized, this wi is our weight. So we see that it's a bit high. Hmm? Okay, what do we do? We introduce this is our gradient descent. This is what gradient descent introduces. And what are these? This is what learning rate. This is what this and this is the gradient of our loss function. So, and why are we subtracting? And we are subtracting it, not adding. There is a reason why. This W1 is what is now the updated weight, the one that we'll now use now. Hmm? So well, use this weight. I'll use this weight. I'll use this weight. We'll calculate the loss function again. Whatever we get in our loss function, we'll use it to calculate our gradient descent again. So it keeps like, and the cycle keeps going. So and in the next phase, this will be at the next iteration. No, this is iteration one. At the next iteration, this wi plus one will be here, and what will now be outside here? If wi plus one is here, what will be here?
Wi plus 2.
Wi plus 2.
I didn't get the question though.
Yeah. This will be wi plus, because that would be like the updated weight for the second iteration. So this learning rate, can anybody tell me what they understand by learning rate?
How like this one is a hard one. But like I just know that it's a hyperparameter, and I really can't do this one. Sorry, but it's a
Okay.
hyperparameter. That's all. It's a hyperparameter.
No problem. No problem. Anybody else wants to give it a shot?
Is it the learning rate with regard to a particular model or just a general of what's it called, saying of a learning rate?
Okay. General learning rate, and if you want to specify it's a particular model,
Okay, like you
you
said,
can
is
give
an
us this.
hyperparameter of a particular, hyperparameter of a particular model. So it's more like you're trying to adjust different learning rates to see if it can affect or reduce the what's it called, the error of the model, something like that.
Okay.
Or should I say?
All
Can
right.
I say? Can I say like is like the speed with? I mean, I don't know. I'm sorry to use like learning again, but like, is it like the speed
Mhm.
with which we the speed with which we descend to the lowest point, something like that. This I'm using the same words like learning and descend, but yeah,
Yeah, isn't it?
that's
Yeah,
what
our
I'm saying.
model is learning. So the thing is, okay, I said we were at this point, right? Hmm? But we want to update it. Hmm? We want to update the. I want to update the weight. Hmm? Learning rates will tell us, okay, how many, like how much step. Let's say you are climbing a hill now. Okay, let's say you are climbing down a hill. Okay. You are climbing down a stairs. Let's say you are climbing down a stairs. You are at the highest point. You are going down to the lowest point, right? Okay. Some of us will take one step at a time. Some of us will take two steps at a time. Some of us will take three, four, five. Some people jump down the stairs. Like, and some people will just jump from the topmost sphere, maybe to the middle and then to the end. And some people will jump straight down. So that is a simple explanation of learning rate. Learning rate is telling us that, okay, when I am here, okay, I am going to this point, right? I'm going to this point, right? How much step hmm, should I take for me to calculate before I calculate the next cost function? Do we get that? So the thing is, it's just telling you, do we understand the concept of the stairs?
Yes, sir.
Okay, so it is just how you move down from. Okay. Okay, so that's basically that is not an answer. It's just how we move from where we are to is the number of steps we take while we are updating our weight, and then in order to get us to the minimum point here. So that's basically what learning rate is. If we have any other question, please. Okay. Okay, yeah, okay.
Um,
So okay. I was
Teddy is
confused.
saying some things in the chat.
Okay.
Teddy
Yeah,
is
yeah,
saying
yeah.
something.
Yeah, when she said why can't we just jump to the end, I thought like okay, it was about time. So when she now said okay. Now okay. When we were saying we want to take why should we take okay since we are here why can't we just jump to this point? Should we take small steps or should we just like jump down here? Or should we just like jump down and hopefully we we pray that we get to the minimum point?
I want to say something. I don't like the way you said that, hopefully. You see, if we say that we should jump down just like that, we might over jump and then we won't, like, we might pass where we are going. So instead of jumping down, then instead of reaching down to, you might jump and then pass to, and then you'll be on four. And then when you're on four, the loss function is higher than it should be. So that's just why we can't just jump. And then the reason why we take small steps is so that, okay, no, it's not like we take small steps or large steps. We have to look for the optimum step to take. So we can't,
Good.
if we take two small steps, we might not even get anywhere. And if we take two large steps, we might over jump where we are going.
Exactly.
So we just have to find the
Yeah.
optimum steps to take.
Thank you for that. So listen, if you we are humans now. We are humans now. I can jump from the top. I know that okay, this is the last step. And once I get to the last step, I am I am like once I get to the last step, I know that I am there already. But the model doesn't understand that. If you take a large jump, if you take a large step from the from here, if we take a large step, let's assume we get here and we don't know that we're already there, and the model takes another large step. It doesn't know if it doesn't know that this is the minimum, it is just it is gliding through blindly. So that okay, you are just like in the also you are you are lost in the bush. You are trying to find your path. So if you take a long step, you won't be able to. If you jump from here to this place, okay. Oh, it's reduced. Oh, we are getting there. Then from here to this point, it is jump because it is jumping. So like it doesn't know that probably it was thinking that probably this point will be the lowest one. Mind you, the model doesn't know which point is the like minimum point. It is trying to find it. Do you get? We already know that this is the minimum point, right? But the model is trying to find the minimum point. It jumps from here to this point. We saw that it reduced, then it jumped here. What happened again? It's like it increased to okay. Then it said okay, let's jump here. The error is increasing again. It will keep if we take too much of a large step, it will keep jumping around. And even if it eventually if it jumps here, it won't even know it won't know if it's already at the it won't know if it's already at the minimum, at the global minimum or not. Do you get? So that's the disadvantage of taking to if your learning rate is too high, you won't be able to converge. It will just be all over the place, zigzag. There won't be any sense of direction. The model will be lost. So that's why you don't take too large a step. If your step is too low, hmm, it will even though you might eventually reach here, but it will take a long time to converge. Even though you might eventually reach it, it will take a long time to converge. And there's also okay, this one now we only have just a single minimum. In real life data set now, there's something called local minimum and global minimum. In this, you can call this one our global minimum. This is the global minimum, right? But there's something else. There's also something called local minimum. Let's say we have like, let's say there's a minimum here, and then it's so let's say there's a. Can you see my Can I see the way I'm doing my, what's it called? My cursor. Can I see where I'm doing my cursor?
Yeah, yeah,
Are we
Yes,
yeah,
yes, yes,
yeah.
yes.
so let's say this particular line, it comes like this. Then there's a minimum here. Then it now increases again, and then before it now proceeds to this global minimum. Hmm? If your step is too small, once your model reaches the point that is here, the local we call that one local minimum. It is, even though it is a minimum, that is not the best the model can do. The best the model can do is still here, right? If your step is too small, your model might just it might be stuck there, and you will feel like that is the best your model can do. Is that clear? So as much as you don't take a step that is too much, you also don't take a step that is too slow. You need a balance of both sides so that for you to be able to get best of both worlds. Can we all see the picture Teju sent in the chat? Can
Yeah,
we see the
yeah.
picture Teju sent?
Yes, yes. Yeah,
I've
it's
tried, I've,
very
I've tried to
self-explanatory.
exactly. I'm even trying to open it from. So yeah, okay. Okay, let me share this. Ah, I want to stop sharing. Okay, just open up that image and see exactly what it is saying. So the image. I think I should let me share this image. I want to share it so that it won't be too abstract. Okay. 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 Let me just go to this site. Thank you. Thank you. Thank you, ma'am. Okay. Can we all see it?
Yeah, yeah,
Can we see the learning step? Mhm.
yeah.
So this is the lead. This is okay. I told you it is initialized at random. Then it takes 2 steps until it reaches the global minimum. Mhm. So now this is if you are taking a large learning rate, it will just be all over the place. It will not converge. If it got here, it still moved because it is confused. And if you are taking a learning rate that is too small, this is what I'm talking about. This is what we call a local minimum. This is the global minimum. So it will, because it is taking 2 small steps here. When it tries to climb up here, to say that the error is in the error rate, the loss function is increasing. Loss function is already increasing. I think this is the best we can do. But if your learning rate, if it is like if it is like balanced enough, once it won't be stuck here. Once it gets it will be able to escape this local minimum. So that is why we need a balance of not high but not too high, low but not too low. Do we understand the concept behind gradient descent? So do you understand that concept, or anybody still needs any further? Is that clear enough?
Yeah, it's very clear. Those two images down there show, like, no, the one at the bottom. Yeah, these two large steps means that you miss the
Mhm.
minimum. Small
Exactly.
steps means that it take time and stuff like that. Yeah. So yeah,
You
thank you.
take time or you get stuck at
Yeah, yes.
somewhere.
Yeah.
Okay. Abdul Shakur, do you have anything? Um,
No, you've actually said it all. Yeah, that's just it. Large step means you might miss the what's called local minimum, and smaller steps. It might take longer time to actually get to the minimum, like that's the global minimum itself. And then sometimes you might mistakenly fall into local minimum instead of global minimum if there are multiple minimums.
okay. Oh, Jojo, no. Sorry, I don't know if I'm pronouncing that right. I'm calling people at random right now. Oh, Jojo, no. Is that are we okay? Taiwo Shobande, Olajide Otolorun. I've not seen you. I'm calling people randomly. Are we okay? Can we proceed? Okay. All right. Let us. I hope we've all filled the attendance form. Okay. So that's about gradients, descent. Okay. Let us go into okay now. Let us do something with a data set. I think our okay. Was anybody able to did anybody run this particular aspect of the notebook? Did anybody run this aspect of the notebook? Okay, I guess not. So okay, I'll just do a brief cap of what is going on here. Does anybody understand what is going on or these two cells? Though this is not in the cell that it's not in the cell that I mean this is not in the notebook that was sent to you. This is just while preparing for I just wanted to show you. Does anybody what exactly am I trying to achieve with this code?
Which cell is this? Cell 23 or
From this one to this and to this.
I don't know. I think you're trying to pull data from Kaggle.
Okay. Yeah, I put, oh, the thing is, this is the link to the data set, right? I can just go there, I can just go to Google and download the data set, which, you know, which we can all do. But I just decided to, instead of doing that, we can all, I think we thought this in, was it, I don't know, earlier in the course, I don't know which week specifically, but we thought we showed how to like how to get a data set directly into your notebook from Kaggle. And and by the way, Kaggle also has notebooks. You can use Kaggle notebook instead of Google Colab as well. So whichever one works. You can use Kaggle notebook, you can use Colab notebook. So that was just me using ah, version. So this was just me using the Kaggle like API. So I already upload this Kaggle the JSON is my Kaggle API and which I downloaded then make directory blah blah. Now to going through. So I downloaded the zip file. So I extracted the file. And after extracting it, this is the zip file. And after extracting it, this is the housing data set. So now we'll be performing a we'll be building a linear regression model on our our data set. So okay, but before we build our model, we need to let us do a bit of exploratory data analysis. I will go through this briefly, and then I also did some things below the notebook. I will take us through that as well. So okay, looking at this, we plot. This is a scatter plot. So we use scatter plots majorly when we are plotting between two continuous variable. So for looking at this plot from your eyes now, what kind of relationship do you think price and area? What kind of relationship do you think they have?
Like,
Are there
are you,
any mathematics to that?
are you talking about
Sorry?
like correlation? Like,
Okay, yeah, yeah, yeah. But yeah,
yeah,
correlation actually.
yeah, it looks like, like they're positively related. Like there's a positive correlation, but I can't, from the graph, I can't tell whether it's like strong or weak. But like it does look there's positive correlation. Like as one variable is increasing, the other one is increasing. As the area of the house or the land is increasing, the price too increases. And that's like actually like a no-brainer. Like in real life, that's what it should be.
Okay.
Yeah.
Okay. Okay, yeah, that's okay. Yeah, this is a positive correlation. Yeah, the thing is, I want time will not permit me to go through this note. This notebook is already with us. I want us to go through it. But before I want to go through my sample stuff with you. But before that, please, everybody, go through this notebook, go through the lab, go through the notebook. Send your questions, whatever you are not clear with. Let us know. The thing is, I'll drop the link to this my own notebook. I'll drop it in the if I don't know if you'll be interested in with it. If you're interested in it, I did some other stuff there. So okay. Now I want to I want to walk us through building a linear regression model. I know that the one our instructor did, it had a lot, where he was trying to explain a lot of stuff. We had a lot of, a lot of what's it called? A lot of things were going on there. So let me just explain this. The first thing we do is that we load our data set, right? And so this is the data set, the housing.csv. I loaded it, and these are the top five rows. So the first after loading the data set, I want to understand my data set. Before building, although we'll be building a linear regression. We're building a linear regression. So before we build any machine learning algorithm, we need to understand our data set. We need to know what exactly is wrong with it. To understand what is going on in my data set, I do. So this I remember I stored my I this is I continued housing df is the name our instructor used to save our the variable our instructor used to save the data sets when he loaded it. So we describe, so this is it, dot describe. So okay, we can say that okay, what is so what how many do we have? This is just telling us the number of values in each column, which is in each column, which is counts. You can see they are all 545. Okay, this is the mean, standard deviation, the minimum value, the 25th percentile, 50th percentile, 75th percentile, and also the maximum value. So all this helps us to just to understand our data set. So I want to understand the information. Okay, I can see the data type. All these ones are what? Integers, and you can see objects. This object what does this object, what does it mean? It means these columns are what? What
And
is it telling us about these
non-numerical.
columns?
That
They are
the columns are
non-numerical.
non-numerical.
Good. So from here you can check. There are times that you may have a numerical column here. But probably assume these stories now. You are checking stories, and then probably when you go here, you see that stories is an object instead of being an integer. So you know that it is wrong. So let us check. Let us check the objects. It's main road. Is main road supposed to be an object? Is zero supposed to be an object?
Yes, yes.
Oh. So we can see main road is supposed to be an object. It is yes and no. So same thing with guest. Okay, let's check guest row. So same thing. So the only columns we expect to be objects are what? Bedroom, guest room, basement, overheating, air condition, this is prefer area, and furnishing status. So which is how many? 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4,
Hi,
5, 6,
hi,
7.
hi.
Yes?
This is Teju.
Okay.
Um, I just wanted to let you know that we're almost on
Oh
the hour,
my God.
but I would really like it if you go through the sample document to give an idea of what we expect from the teams this weekend. So that like we can make progress on that as well. I'm glad to see that a lot of people have formed groups, and I encourage people who haven't to continue to reach out on Discord, on the chat, share your ideas and your interest and come together. But Yomife, you prepared a document just to give an idea of what we expect from the teams, and let's go through that before the end of the class, and we can also provide this notebook as part of the many different documents that we can share to the team to give an idea of how to prepare for the project. Yeah.
Uh, okay, let's do that. Okay. Mobile network. Mobile. Okay. Hi everyone. Hello again. Okay, so are we all? Can you see my screen? What can you see?
The capstone project.
Exactly. So this is
Capstone
my own.
project.
Okay. Okay. This is my own sample project proposal that I came up with based on my own. This is this based on this problem I want to solve. So cohort capstone project. So the team name is what Nigeria State Analytics. This is my phone name, Gmail, and username on GitHub. So team members. Like we said, only the team lead should fill the form. But you see this document, you see everything that we wrote here. It's not only one person that should write it. the whole team is contributing to this, so it shouldn't fall on just one person. Everybody should contribute to you can have a Google Docs, a Google Doc. I think that way you guys you all will be able to like collaborate easier. So and then you keep updating each aspect of the project. So this is a sample of what we expect from each team by next weekend. So okay, project. This is my project title: Predicting House Prices in Nigeria using machine learning.
Um,
Okay.
yeah, Professor, could you scroll up, please? Okay, so the team name, it's nice. And I was also wondering if we could have a theme for this cohort. So last year we had a theme of African president, past president, as the team name. So we had like Kahunda and John Salif and Tehon. So maybe this year we could do African um,
Agents.
literatures, right?
Okay.
So for example, we have Team Shoyinka, Wale Shoyinka, can think of
Chinua Achebe,
yeah, Chinua Achebe, Chimamanda,
Chimamanda.
and so on. So, just an idea. There's a Nigerian boat, but there are also others from many African countries you can check out to inspire. So,
Okay. Yeah. So let's put that in mind. So I'll update the form and include. So this is my Team Shoyinka. This is my name, and these are my team members. So project title: Predicting Housing Prices in Nigeria using machine learning. Okay. So what exactly is the problem? Hmm? Okay. I found okay. We all know Nigeria's real estate market is vast but lacks accessible and reliable housing price data. Everything depends on what agencies say and probably what the landlord is coming up to. Whatever a landlord is, whatever is convenient with, and whatever the agent is saying. So there's no actual what do I call it? There's no actual metric to evaluate housing prices in Nigeria. So I said, okay. My problem is that is the problem. So our project aims to build a predictive model to estimate housing prices accurately based on property features such as the number of bedrooms, number of bathrooms. These features that are present in my data sets. Um, I'm using a cargo data set. Let whatever data set you're using, ensure it is publicly available. And if you'll be the one that if you are sourcing the data, probably you want to scrape the data, probably you want to source for the data, or you want to like even use a questionnaire. There is no harm in doing anything. You can go as high as you can. We are here to support you. As long as it's still within the scope of this project, we are here to support you. So this is the data set. So parameters, bedroom, bathroom, blah blah blah. So okay. So that is my data set. So I'm talking about the features that's actually present in my data set. This is to tell you that I am already familiar with what I already understood what I want to do, and I have gone through my data sets. So our project is to build a predictive model to estimate housing price accurately based on property features such as number of bedrooms, number of bathrooms, number of toilets, availability of parking spaces, the house type, the town, and the state. This solution matters because it provides transparency and promotes informed investment decisions and contributes to more efficient real estate market operations. So this will also help developers or investors to probably a landlord. Okay, I want to buy a land I want to buy a land in the specific area. Okay, I already so even before buying the land or at the point of before buying the land, I already know okay, if I build this, so can I put to properly plan that's okay if I'm building this, this is the amount I can rent out my apartment. So like that. So I am able to communicate my problem statements, what exactly is wrong. So and then what are the existing solutions that people have done? Then what are their general housing price prediction platforms like? I provided examples. Most existing solutions are not data driven. They just like listed. It's not there's no specific data, there's no specific metric. So they are not data driven. So it's based on what the developer and landlords feel is right. So this project differentiates itself by leveraging a comprehensive cargo data set, applying robust machine learning techniques, and providing an interactive deployment, both for individuals and organizations, ensuring a transparent process for both parties. So I'm able to communicate what I want to do and I'm able to tell you what the existing solutions and what I am doing differently. So what am I going to be doing? My objective, clean and process the housing data set for accurate analysis. If I am scraping the data set, I will include it in my objective here. If I'm going to be doing a survey, I will include it here. However, I'm going to be getting my data set since my data set is already like publicly available, so I'm not doing anything beyond that. But if you want to scrape your data, if you want to get your data from wherever, include it here. So also explore data trends and perform exploratory data analysis to uncover patterns and correlations. And then build regression models. Why am I building regression models? Because the target is a continuous is a continuous the continuous variable. So to predict housing price based on key features. And then I'll be evaluating model performance using metrics such as root mean square error and okay. You guys have not sorry. I'm not sure if you understand the concept of root mean square. Okay. Oh, sorry. I already talked about root mean square error, but it is this natural theory that we haven't really talked about. So so finally, I'm planning to deploy the final model for public use on a web interface for easy access. So for web interface, I think I specify somewhere that I'm going to be using Streamlit web app. So I was using Streamlit web app. So this is my data set. I said why I am choosing this data set. So it said it provides a comprehensive collection of housing features across multiple Nigerian cities. So not just one city. So it is ideal for predicting modeling and aligns perfectly with our ML objective and represents real world data challenge relevant to the local context. So I need you to think through or whatever you are doing and be able to like come up with a structured answer. So this is the methodology. And then, so I'll be doing feature engineering. So to transform categorical column using what I'll be to transform one not categorical column using one not encoding. And I'll also be doing bathroom to bedroom ratio, bedroom to toilet ratio, bedroom to toilet ratio. These are just to increase my data set and to introduce whatever feature is not present in my data set before to introduce it.
Oh,
So
Yamife, thanks a lot. I just wanted to quickly mention here that, of course, like it depending on the problem you're choosing, you may not have all of this information yet. But the whole point is to make sure that you do as much survey as you can. Maybe you read a few literatures, look at a few projects that you're modeling yours after to understand how they had done it and how what you may be doing or doing differently. This can give you an idea. Or so if you have the methodology, if you already like really think about it and write it down, it provides you a plan for your project. So now that Yomife has written down that it's going to be cleaning the data set, is using that as a way to okay, what do I do next? I only have like 3 or 4 more weeks before the project presentation. Who's doing what? We need to remove outlier because most of this, the way we have written down the methodology is how we would end up writing the project report or like the project presentation. So it becomes like a plan for you. But as you do a project, things will come up. It's natural. You would use other tools. You might like, find yourself seeing things that you actually didn't really anticipate or didn't even know that the previous projects that you were modeling after went through the same problem, which brings you a unique perspective that you can write about or like say, okay, for future, this is something that came up and future projects should also think about, and it can help other people that are modeling their work on yours to give them a baseline as to what to think about. Yeah.
Oh, okay, thank you. So it is possible to not, as Teju said, it's possible to not have everything like fleshed out already. So, but you should have like should have something you are modeling your work like after. So you should have like a guide that you are following. So eventually, though things might change, things might when you are working on things, there will be differences that will be introduced, or probably there are some things you didn't like recognize or didn't notice while you were writing the proposal. So that is fine. That is fair. If you are not saying that everything should be like everything might not be sorted out yet, and everything might not be so clear right now. But you want to just have, okay, however you are going, you have a plan and you already know what you are going to. So these are the models I plan on testing. If or I plan on working on. Eventually, I might what the model that might eventually give me the best performance might not be any of this. I'll still try multiple models and see compare their performance. I'll optimize them and perform and compare their performance and see. So I will eventually go with the algorithm that gives me the best performance. So these are just like what this is like how I plan to like go about the work. So it is not so exhaustive, and depending on the problem you're trying to solve, you might not your the problem you're trying to solve might not like necessarily need machine learning. It depends on what exactly you want to do. It might not, like it might not necessarily need building a model. We covered a lot of topics, a lot of aspects we've covered a lot of aspects in this course, and we'll still cover more. So it's just you understand what you want to do. We just want you to have like an idea of what you want to do. So you have like give or take a bit of an idea of how you want to do it. So you are not when you start, you are not like lost, and you don't. It's not like you don't know where you are going. So these are the models I plan to work on, and then I'm deploying the model. So I said I'm deploying on Streamlit. There are different deployment platforms. Some people can deploy it on Hugging Face. There are people that can, and if you want to use fast API as the backend, yes, there's no harm in doing it. So should I tell them about
What is it, please?
the about next week?
Oh yeah, for
The
sure.
guests.
Yeah.
Okay.
So next, I think I mentioned this last week as well that we're gonna have a guest instructor to go through deployment, how to deploy a model on apps like Streamlit. So Femi is going to make an appearance to give a lecture on that next weekend. So we'll send you more details, but that's the current plan.
Okay. So deployment and expected outcome. What I'll be working. Okay. So a robust predictive model for housing prices in Nigeria. Yeah. Insights from EDA highlighting key factors affecting house prices. So these are what I am expecting to come. And these are um I really love this this was from quote 4 machine learning. I really loved how she like no it was not a it was the way she wrote her reports, her project reports. So I really loved the way she wrote the reports. This was also quote 7 also. This project in quote 7 it also like also similar to this particular so I picked from a lot of things and then decided to write mine. So this is not exhaustive. This can just be like, please don't copy it. Don't like do copy and paste. Just like we just want you to understand and give a format so that works with you. So this is a format, and then you can now like personalize it, then fit it. You can follow this format and then aside that, Seju showed us on the on can you see the digital page? Can you also see the digital page? Okay, so you can check through previous quotes. You can check through different all the this is quote 7. You can check through their projects. So where is the project? Okay, this is the project. It's called 7 projects. So you can check it out, and you see these are some of the projects from port 7. You can also check from port 8, and then there are a lot of projects to inspire you. So we already have a collection of different projects that can inspire you within this in this so this is course 8. You can try course 7. Then you can even try course 1 to 4. Even earlier course. Uh, okay, so you can see projects from course 1, course 2, so, and much more. So you can browse through, read them, let them inspire you, and you know, okay, and
So can
explore.
we, so is it possible? I mean, while you were doing this, though, I quickly wrote down the headings for this proposal, so that my team and I can use it. But like, is it possible to still get this? Is this a template? And can we get it or no?
This is a template. Everybody will get it. Everybody will
Okay,
get it. It's just
okay,
that what you are just saying that let it inspire you. This is not the
okay.
only. This is not the only sound. This is not the only one. I just like showed you through different projects and different
Actually,
projects. Like
as we were doing this, Yomife, I think what we should do is to, I mean, of course, we'll give this as a template, but let's remove the team leader's full name and email or Discord. Let that be in the form, and then in that same form, they should link to a PDF of this proposal with
okay,
the same template. So this way we can take that PDF and put it in each of the projects repositories. So once we receive your proposal by next weekend, we're going to create a GitHub repository from within AS at the Lagos GitHub with your team name. As you've seen in the previous cohorts, we had like Team Kahunda, Team Johnson Selef, and other team name like that. So whatever you put there as your team name, for example, Yomife has Team Shoyinkai here. We will create a repository there, and we would add all of you, the team lead, and give you the admin access so you can always take ownership of that repository. So maybe in addition to including name, email, Discord, you put your GitHub username in the form that you would submit, so that we will use that to help set up the admin part of the project and we can have like a structured cohort 9 project that is all like in one place. Is that okay?
Yeah, I think that's okay for. I mean, if you're talking to us, yes, that's okay. Yes, yeah, yes. Sorry.
Yeah,
Then,
yeah.
okay. Then I sorry. In this project, is this something that the team can start working on now, like the proposal
Yeah, yeah,
implementation?
you should start working on it now because the deadline to submit it is next week, Sunday,
Okay.
right? So, after the call, we'll send out the details and also this template as an inspiration, and by next weekend, I expect to start seeing submission. I looked at the form as of today. No one has submitted yet, but I understand you're still forming the teams and you still have to write the different problem statement and things like that. So we got one more week to go. But great job. I was really inspired to see yeah, like expressing what you're interested in and just organically forming teams. I think that's really nice.
Okay, thank you. So yeah, we'll change, we'll edit the form, we'll update the form that we sent to you. Same link, we'll update the form, and yeah, then we'll send this template and any other information than that. Um, okay. Any question regarding the project so far?
Yeah. So the project, is it supposed to be? Is there like it's meant to be a regression project, right? Or
It can be it can be a regression, it can be a classification,
okay.
anyone. But it just how do I want to say? Surprise us. Let us see.
Yeah, it's not like it's mostly you should be able to use all the models, the different models you learn about and like in this cohort. Look at the schedule we have for cohort heads. You've learned about linear regression and classification. You would learn about recommender systems and you learn about nonlinear modeling. There is another lecture on each one from trying to remember from Yeti.
Like a probabilistic
There's probably
project, and I think NLP.
yeah, we've already done
I
NLP
mean,
now.
sorry, I mean deep learning. Right.
Yes, there's deep learning, so you
Should-
can do projects on deep learning because that's also covered. There's decision tree and interpretable models. That Yeti taught. So like there's a bunch of models here that would be touched and the models can do different kind of task. So there's the classification task as you've learned and a lot of the things we discussed today was regression. So the house pricing is a perfect example of a task that you can use regression model on. But if we were talking about spam classification, that you wouldn't naturally use a regression model for that, right? So just think about it's not about the model itself, it's about the problem you want to solve. Like what's the signature nature of the data you're looking at? Are you trying to do a classification task or a recommendation task or is it like a semi-supervised learning or are you thinking as in like you have an agent and you want it to move around, which is out of scope because we're not teaching you reinforcement learning. So thinking that way, think from problem, and then it's like what data do you have, and then what is the goal or the task for that? Does that answer your question?
Yes, yes, very yes. That does answer the question. Sorry, I'm asking too many questions. I have one more question too. So like, you said something about at the beginning of this today's session. Mr. Yemi first said something about the NLP project for like, is it last week or the previous project? So like I just got a team now on the call, like on Discord. So we're already like team Ben Okri already. We've already agreed on the name and everything. So can we still do the NLP project while still doing this one? Or we should just forfeit that one and just focus on this?
NLP is covered, right? Somehow in this.
You
If you have I mean, if you,
have the
I've
bandwidth.
not, I've not read your proposal, so I don't know what you wanted
Exactly.
to do. So this is why the proposal is also important because it gives us a sense of how to guide and support and see if there is enough tools in the cohort that you've learned that can help you with that project. But you can be ambitious. Not everyone is on the same level. So you can use different kind of tools. You can blend and mix and match if you're able to pull it off, right? So I would like to see what you come up with. Again, I'm interested in problems. Um, Simplifying this to make it work for the cohort, it's just to help people who are still very new to all of this concept to not feel overwhelmed. So you know, like where to start from. But if you're a little bit advanced and then you have some member of your team who are just coming up and you're able to like you have this ambitious problem you're thinking about, but we can scope it to fit within the cohort, you know, why not go for it? At the end of the day, it also comes into it would go into your profile. You can experiment, but you need to have the tools. And with the proposal, we're able to gauge and to advise and to help to rescope if it's needed to say, okay, you're going to need X, Y, and Z. It's not going to be taught. How do you intend to fill this gap? Or can you think more about going in this direction that helps you to be able to use the tools that you will learn or you've already learned? So I also encourage you to look at the cohort structure page to see like all of the lectures that will be taught as you start to think about your problem and what you want to um, solve.
Yeah, thank you very much. Thanks so much. I appreciate it.
You're very welcome. And maybe lastly, what to say is that depending on the number of teams that we get, and we we could also support in terms of like mentors. We've mentioned last week that we've always tried to do that in each cohort to have someone check in on the team and help provide some guidance. So like once we receive all of your proposals, we can look within our teaching team to see who's available in the next few weeks. We would like to dedicate an hour or two to the teams in per week or something like that. But that would come later. First, need to see the suggested project that we have, and then we can go from there.
Okay. All right. Thank you very much. I hope everything is clear. You don't have a group yet, so if you please reach out on the Discord channel, and you can also reach out here. People that are yet to form a team, you can also reach out to him, form a team, and choose a group leader, and you guys can work together to make this dream come true. Yeah. How do we? Regarding the notebook, I'm not sure if we're able to. Oh, our time is fast spent. 12:32. But was has it been? How has been the session so far?
So maybe what we need to do for maybe we would have to do the same thing we did last week if people are interested. And another 1 hour catch up with you. If you have the time. Because I see that we still have a couple slides that you've not been able to go through.
Yeah.
Yeah, so maybe we can jump to what's happening next week, and then
Okay.
you know, if you want to continue later this evening for an hour or so, you can write in the chat, and if Yomife is
Okay.
available, of course. But yeah.
So is there no how is our schedule this evening looking like? Should we just end it here? Uh, it seems people are not interested, so I guess shall we end it here or only one person? Okay. Okay. While we are still waiting on that, let me just like talk about our schedule for week 7. So tomorrow we'll be going into week 7, and we'll be going into the pastors. So which is why I want us to understand this aspect, because our understanding of this aspect is what will drive next week, and we also like it also will like make us know if we'll be how will I say is this also contributes to our projects, because most of us will be working on many of us will be working on we'll be building machine learning models, we'll be using machine learning algorithms. And for us to build models, we need to understand what exactly is going on, so we know what exactly to do and how to make these things better. So, we have been doing linear regression so far. By by next week, which starts tomorrow, we'll be going into non-linear modeling. So we've been assuming, we've been assuming that all these all our data, they have a linear um they have a linear relationship, which is not always true. So if our model is not if our data doesn't have a linear relationship, what do we do? So there are different methods that we can always try. So I will be going into that this coming week. So I need us to understand it. So if we'll be available this evening, I can try to make something happen this evening by that 8 p.m. Yeah, 8 p.m. We can do 8 p.m. 8 to 9. If you're available, then we can make it work. Then yeah, next week we'll be going to decision tree and tree modeling and all the other advanced algorithms. So if you understand this process, which the next week we'll build on it. And our assessments, so for the coming week, we'll also build on our assessments this week. So our assessment next week will be trying out these advanced models. We'll be doing different. Well, we'll be optimizing it and doing different. We said hyperparameter tuning. We'll be optimizing it using different methods, and we'll be comparing our findings. Well, using these powerful algorithms and these these ones. And also there's also hyperparameter tuning will also be going into it this coming week, because we'll be seeing how to do cross validation and other powerful ML algorithms. So if we're interested, I can squeeze that in. As Please don't forget to submit this week's assessment by tomorrow, by the end of the day tomorrow.
Sorry, please. Where can I get, like, how do I access this week, like the assessment? How do I access that?
Okay. I will. Okay. I'll drop it on the. Are you on the Discord channel?
Yes, yes, I'm on the Discord channel. Yes, sorry, yes.
Okay.
Is it possible if I can get your username to just to? I promise I won't bug you. Just in case I want to
No,
find
no,
out more
you see,
information.
no problem. Yo,
Okay,
this is your fair on Discord channel. You're like I will always drop message people to tell them they can handle this man.
okay,
So don't
okay,
worry, once you see my display then you will know it. So just so someone, okay, as we are talking, someone should just like drop the link to the assessment in the Discord channel so you'll see it. Yeah. Download the course calendar, add it to your calendar, and don't forget whatever information you are looking for can be found on our um can be found on our GitHub channel, GitHub page. So every information regarding the course. So and if there's anything you feel if there's any information you feel you need, you can always reach out to us. So thanks so much for joining us. Um, it's nice having you all around. Thanks so much for standing. I do for standing by us for everything. Thanks for pushing through. Thanks for waiting till now. Thanks so much. Um, I thought I saw Tola earlier.
Yeah. So just wanted to also shout out to Yummy Fair for um his superb organization. This is like week what? Week six. It's not easy to stay consistent, guys. It's not easy. And this is his very first airs at the Lagos, and so he's been pushing through. And just specifically wanted to shout out on the call, and so thank you. And I recently learned I was not feeling too well this week, and he still pulled through. So um yeah. When you can, send him a shout out and thank you.
So much for that.
What's even harder to be like be the one facilitating the class is that just as you have to go through the materials, he also has to do that. And he doesn't even have a choice. He needs to actually go through all of it because he needs to be able to prepare the slides and explain in case you have questions. Maybe you didn't really go through everything. Maybe you only went through one of the materials. So imagine if there are like three videos to watch this week, is trying to like catch up on all three and trying to catch up on the notebook as well, because it's not the one that taught those videos. It was not the one that make those notebook. Those are classes from cohort 8, but is um, helping to facilitate this and make sure that you get all of the knowledge, or like even like debug in case there's been some problems. So just wanted you to have a glimpse into that. So maybe next time you're the one facilitating these classes and helping other people, right? So um, we have I am because we have the spirit of Ubuntu. So thank you, Yamifer, and thanks everyone for being here. And well done, really well done. Great job. I hope the cohort has been enriching for your whole, and you're looking forward to the project.
Hello?
Yeah. Yeah. Thanks so
Hello?
much, Stephen. Hello, we can hear you.
Okay. Sorry, I have a question to ask. Thank you so much, Mr. Ju. It's concerning this that gradient descent approach normally. I know of normally like Sky Kids Learn has like this sort of built-in library function to like fit the model normally. So I just wanted to know whether for like this capstone project, and like can we just directly like use the Skyscape-learn library to like in case we are doing like something
Chitom,
related to.
yeah, no, Chitom is fine. We're not asking you to implement these things from scratch. It's used the libraries. We teach you to understand how it works, but If you look at the notebook that we also share, we use these libraries like whenever we need to. So to your question, yes, use scikit-learn models to build this and test a lot of models, but you need to understand how they work to some extent so that you can, the kind of features these models are looking at, how to compute some error, you can explain it to someone what you did. This is one of the most important things to consider.
All right, thank you so much for that. I guess does anyone else has any question before we call it a day? While we are waiting, Tola, do you want to say a few words to everybody? Hi, Miss Tola, are you there? Okay. If that is all, okay. I guess we can call it a day.
I don't
Thanks so
have
much, everyone.
anything to add.
Okay.
Well done, Riyami. Well done, everybody.
Thanks so much. All right. All right, I'll be expecting it to roll. All right, everyone. Have a nice day. Catch you as much as those that will be available. Catch you in the evening later. Bye bye.